about another minute to try these two problems. So first one should be fairly straightforward. The second one is a little bit trickier. Just to clarify, you're finding the area of the triangle that's shaded in. That shaded area is what you're finding. So you should use the measurements that are relevant to that triangle. All right, here they come. Since this triangle is using this smaller shaded triangle, then this 13 should be what you're using for the base. The rest of it is just using and showing the fact that that height of 7 is perpendicular to the 13. So here are your answers. Take a minute to check those, see if you have any questions. Didn't ask for perimeter, just for area. By the way, if we put units on this, this should all be in units squared. Units squared for area. All right, let's do this next one. This next one is a trapezoid, so here's your area formula for a trapezoid. So we need to plug in and figure out our pieces. Now, in a trapezoid, the bases are the lengths and distances that are parallel to each other. So in this case, our bases that are parallel to each other are this length and this length. Those are our two bases. And then just like with our triangles, our height should be perpendicular to the base. Height should be perpendicular to the base. Another way to say it for the trapezoid is that the height connects the two bases together. So here is my height. So that's your two bases and your height. Go ahead and take a minute, figure out what those are, and see if you can plug in the right pieces into the right places here. And remember that your answer should be in units squared on this one. Hopefully you're getting your height to be 1, 2, 3, 4. For the height. And then my bases, the top base here is 1, 2. My bottom base here is 1, 2, 3, 4, 5. So 2 and 5 are my bases. We're going to add those together, which is 7. So I have half of 4 is 2 times 7 is 14 units squared. For my area. So that's your trapezoid. Bases are parallel. The height connects the two bases together. Say again? Which ones are you talking about? Yeah, if we were to put units on them, a lot of times I don't put units when there's not a label on them, but if you wanted to put units squared here, units squared. That's for area. Any area should be in any units that we have squared. So when we worked up here, when we figured out area of these shapes, this was in centimeters, so our units were centimeters squared. Here, this was kilometers, so our units were in kilometers squared. If it doesn't have units, then I won't take points off for not having units, but if you wanted to put units squared, then that's what you would put. But if it gives you a label in the problem, then you should have a label in your answer. So in this next one, I'm going to make sure that we put a label in our answer. This is a triangle. And this one's a little bit different. I'm going to go ahead and write down the formula for my triangle, but it's going to look a little bit different. Because take a look at what we are given. We are given that the area is 399 inches squared. So we are given the area. The piece that we're trying to solve for, the thing for x that we're trying to solve for here, is my base of the triangle. Okay. We are trying to solve for our base. We are given, the measurements we are given is that the height is 21, and my area is 399. So we already know the area, so we can put that in for A. And we're going to use that to solve for H. The base we don't know. That's what we're trying to solve for. And then our height we know is 21. It's perpendicular to that base. So we know the area, and we're trying to solve for some other piece of it. Easiest way for this equation is to simplify on the right side and say, oh, half of 21, that's going to be 10 and a half. And then I can just divide by that to solve for B. So I get B. When I divide by that 10.5, that's going to give me 38. And inches, not inches squared because this isn't an area. It is just that length of that base. So our units should just be in inches.